Hi. For decades, computers have transformed the world around us. But scientists now believe the next revolution may not come from making computers smaller or faster. Instead, it may come from completely changing how computers think. Quantum computing is one of the most fascinating technologies humanity has ever attempted to build. So in this channel and in this video, we will see about the quantum computing, and we will start with to know what is quantum computing. In this video, we will explore why traditional computers are reaching their limits, how quantum computers work differently, what qubits and superposition really mean, and why industries like artificial intelligence, cybersecurity, healthcare, and scientists research are investing billions into this futuristic technology. So every phone, laptop, gaming console, and supercomputer today relies on the same basic system called classical computing. These machines process information using tiny electrical switches known as qubits. A bit can only exist in one of two states at any moment, either 0 or 1. This system has powered modern civilization for decades, but as our world becomes more processing and dependent on artificial intelligence, climate simulations, scientific research, and massive data processing, classical computers are beginning to struggle with certain types of problems. Some calculations may take years, decades, or even longer using traditional computing needs and methods. Engineers continue building faster chips, but physical limitations such as heat, energy consumption, and transistor size are becoming more obstacles. This is why researchers are now exploring entirely new approaches to computation. Instead of simply improving traditional machines, scientists are asking a much bigger question. What is computers could operate using the strange laws of quantum physics itself? This question is what gives birth to quantum computing. So, quantum computers are fundamentally different from the machines we use every day. Instead of relying on classical bits, quantum computers use something called qubits. A qubit behaves according to the unusual rules of quantum mechanics, the science that explains how particles behave at incredibly tiny scales. Unlike a normal bit that must be either 0 or 1, a qubit can exist in multiple possible states at the same time. This property allows quantum systems to process information in ways that appear almost impossible from classical perspective. You can imagine a classical computer as someone checking one path at a time through a maze. A quantum computer, however, can explore many paths simultaneously. This does not mean quantum computers instantly solve every problem, but it does mean they may become extremely powerful for specific tasks involving huge amount of possibilities. Scientists around the world are now building experimental quantum hardware capable of controlling these delicate quantum states. To understand quantum computing, we must first need to understand the difference between bits and qubits. The classical bits are simply and predictable. They behave like light switches that are either turned on or off. Qubits are very different. They can exist in a combination of both 0 and 1 at the same time until they are measured. This strange ability is called superposition. A useful analogy is a spinning coin. When a coin lies flat, it clearly shows head or tails. Similarly, at a classical bit or similar to a classical bit. But while spinning, it exists in a kind of mixed state where both possibilities, either heads or tails, are active. Qubits behave somewhat similarly, although the real quantum behavior is far more complex because multiple quantum states can exist simultaneously. Quantum computers may process enormous combinations of information much more efficiently for certain problems. This is one of the reasons why researchers believe quantum computing could dramatically reshape fields like chemistry, optimization, machine learning, and scientific simulation in the future. Superposition is one of the most important ideas in quantum computing, and it is also one of the strangest. In classical computing, information moves step by step through a sequence of calculations. But in quantum state, qubits can represent many possibilities simultaneously through superposition. Imagine trying to solve a giant maze with millions of possible paths. A classical computer may test routes one after another. A quantum computer, however, can evaluate many possibilities together using quantum states. This creates the potential for extraordinary computational power in certain scenarios. Superposition does not magically make quantum computers faster at everything, but it allows them to approach problems differently from traditional machines. Researchers believe this capability could eventually help with tasks like discovering new machines, modeling molecules, optimizing traffic systems, and improving artificial intelligence systems. Even though the science behind superposition is incredibly advanced, the core idea is surprisingly simple. Quantum computers are powerful because they do not think in only one state at a time. Another remarkable concept in quantum computing is entanglement. When qubits become entangled, they form a deep connection where the state of one qubit becomes linked to another, even if they are physically separated. Albert Einstein famously described this phenomenon as spooky action at a distance because it seemed so strange and counterintuitive. In quantum systems, entanglement allows groups of qubits to coordinate and share information in ways classical systems cannot easily replicate. This connection is one reason quantum computers may eventually solve extremely complicated problems more efficiently. Scientists are also exploring how entanglement could enable future technologies such as quantum communication and the quantum internet. These systems may someday allow incredibly secure communication methods using the laws of physics themselves. Entanglement remains one of the most mysterious and fascinating discoveries in modern science. Even today, researchers continue studying how to control and stabilize entanglement quantum states inside experimental quantum hardware. Quantum computing matters because some of humanity's biggest challenges involve massive complexity. Artificial intelligence systems require enormous computational power. Drug discovery involves simultaneous interactions between molecules and that become incredibly difficult for classical computers. Climate prediction models process huge amounts of environmental data. Financial optimization systems must evaluate countless possibilities rapidly. Quantum computing could eventually help accelerate many of these tasks. Researchers are especially interested in quantum simulation, where quantum computers model systems that are naturally quantum themselves, such as atoms and molecules. Cybersecurity is another major area of interest. Some current encryption methods may become vulnerable to future quantum algorithms, which is why governments are and also companies are already developing quantum safe cryptography. While practical large-scale quantum computers are still under development, the long-term impact could be enormous. This technology may not replace classical computers, but it could become a powerful tool for solving problems that are currently beyond reach. Many industries are closely watching the development of quantum computing because of its potential future applications. In healthcare, researchers hope quantum systems could speed up drug discovery by accelerating simultaneous complex molecular interactions. In finance, quantum optimization may improve portfolio management, fraud detection, and market prediction systems. Logistics companies are interested in solving massive routing scheduling challenges more efficiently. Climate researchers believe quantum simulation could help create more accurate environmental models. Artificial intelligence researchers are exploring whether quantum states might eventually accelerate machine learning algorithms. There is also growing interest in the idea of quantum internet, where quantum communication techniques could enable highly secure information transfer. Although most of these applications are still experimental, investments in this quantum technology are rapidly increasing worldwide. Governments, universities, and other technology companies are competing to build practical quantum systems that may define the next era of computing innovation. Quantum computing is still in its early stages, but progress is accelerating rapidly. Companies like IBM, Google, Microsoft, and many startups are investing heavily in quantum research and quantum hardware development. Scientists are working to build systems with more stable qubits, lower error rates, and better quantum circuits. Although today's quantum computers remain limited, many experts believe the technology and could eventually transform science, machine learning, artificial intelligence, cybersecurity, medicine, and future computing itself. This field is also creating entirely new career opportunities for students, engineers, researchers, and software developers. What makes quantum computing especially exciting is that humanity is still at the beginning of this journey. The internet once seemed experimental and uncertain as well, yet it completely changed civilization. Quantum computing may follow a similar path over the coming decades. The next generation of breakthrough may come from people who begin learning these concepts today. Quantum computing represents a completely different way of thinking about computation. Traditional computers rely on bits that process information one state at a time, while quantum computers use qubits that can exist in multiple quantum states simultaneously through superposition. Combined with entanglement, these systems may eventually solve problems far more efficiently than classical machines. Although the science behind quantum mechanics can feel strange and mysterious, the overall vision is surprisingly clear. Researchers are building computers designed to tackle problems involving enormous complexity. Industries such as healthcare, cybersecurity, artificial intelligence, logistics, finance, and climate science are already preparing for the impact of this technology may create in the future. Quantum computing is not about replacing everyday laptops or smartphones, but instead it is about unlocking new computational possibilities that were previously impossible for practical or impractical things. The technology remains experimental today, but rapid progress continues around the world. Just as the internet transformed communication and artificial intelligence transformed automation, quantum computing may eventually redefine what computers are capable of achieving. We are witnessing the early stages of technological revolution that could shape the future of science and human innovation for decades to come. This is the only beginning of quantum computing journey. In upcoming videos, we will explore qubits, superposition, entanglement, quantum circuits, and real quantum applications in simple and exciting ways. Subscribe now and continue exploring the future of computing with us. Have a good day.